Okay, I'm here with Brett with Thrive Energy, and we're actually at the Kelowna Home Show. It's really slow, so we figured we'd do a video, talk about what you do, Brett, and a little bit about what we do. With our building shops, barns, and garages, we don't really use someone like yourself. So what you're doing is you're making sure homes meet step code compliance. Is that right?
That's right, yeah. So we build energy models of houses before they're constructed. Like, let's say if you did need to go through step code with one of your projects, we'd get in at the design stage to make sure that they're gonna meet all the efficiency requirements, build an energy model, and then we test at stages throughout the build to make sure that it's on track to pass energy compliance.
I have a little bit of an idea of step code and what it is, but tell us what is step code, like what's energy compliance? Because a lot of people don't really know.
So BC's got this tiered building code through 5 steps till 2032, which is basically buildings 70% more efficient or net zero ready. So every couple of years, code's increasing as far as energy efficiency requirements, airtightness targets, all sorts of that stuff. Basically, we're trying to minimize greenhouse gas emissions from our new construction and existing housing as well. So tiered energy code is a way to gradually increase requirements to build more efficient houses.
What are the benefits to someone, meeting these requirements and building super energy efficient home?
Reduce operational costs, reduce greenhouse gas emissions from housing, less heat loss, comfort, durability, and health too is another thing. So, we want to make sure that as we're sealing up buildings that you're not making the indoor air quality worse, and looking at things like radon and VOCs of the materials that you build with.
What's a VOC, just so you understand?
Volatile organic compound. So things like different paints and even carpet is a big emitter. So it's things like if you build your house with spray foam insulation, there's going to be some off-gassing of these materials that you build with for a duration, so you want to make sure that you're ventilating the house properly.
So there's 2 types of people, right? There's probably people that are like, what's the cheapest way we can meet it? That's probably one of the types of people you run into. And then there's probably we want this as efficient as possible. What are the major things we can do? So let's speak to the first one. If you're just trying to meet it, you don't have a massive budget, you just want to, as cheap as you can, get it done and meet the step code. What are the best ways to do that?
So it all depends on the housing type and the structure. So simple structures perform better typically, like structures like these, where 4 corners, not a lot of intersections or different ceiling types, less areas for heat loss basically. So the cheapest way to comply with step code or energy code is to look at the geometry of the building and how complicated it is. Window to wall ratio is another big one. Everybody wants a lot of glass these days, and glass lets out a lot of heat. If you don't want to do high performance glass like triple glazed windows and stuff, reduce the window to wall ratio.
But I want lots of glass.
So if you want lots of glass like everybody does, glazing is going to be the biggest one. Try and go to triple glazed glass. Good U values, low solar heat gain coefficients, high insulation values. Basically, we want to look at the building envelope first. That's going to be the amount of heat loss that you have and the comfort side of things. So improving the building envelope, getting efficient mechanical equipment in there, and bring the air tightness way down. And then how you get to actually net zero is by you bring all your operational loads really small, and then you can offset those with renewable energy. And that's how you achieve a net zero house.
What do you think of these buildings, like the way I've described to you, with the metal inside, metal outside, it's got the posts 8 foot on center, so not much thermal bridging. Minimal windows, the overhead doors obviously going to be a bit of a problem, but what do you think about them overall for efficiency?
I think these buildings will perform really well because they are simple geometry. Like you said, there are 28 in the walls, which is way better than our typical 2x6 wood frame already. I think that they would perform really well.
The overhead radiant heaters, natural gas ones that people put in shops a lot of time? I was talking to a fellow that had that and the in-floor heat. He had both, both on natural gas, and his in-floor heat was 10% the cost of using his radiant overhead, so he just quit using the overhead one.
That's the biggest thing too. One of the bigger things about energy efficiency in buildings is that typically we've put in fairly large HVAC systems to condition our indoor environment, but if your house is inefficient, you're just having this large turnover of air and you have to heat a large volume of air. So the more airtight your building is, the more thermally effective it is. You can size HVAC, you save money by putting in smaller systems because there's less heat loss out of your building. You don't need a 100,000 BTU furnace or an 80,000 BTU furnace or a large boiler because the building's not losing as much heat. So you need a smaller system, so you save money. You spend more money up front building it, but you save money on the operational side. And
big time. You hear both sides, like, oh, the old houses breathe and that's better and whatever. I guarantee you've heard that.
Everybody says that,
And then with the new ones, you have to do an air exchanger, like you talked about for the, you don't want radon gas or the off gassing collecting. But there's definitely an air exchanger running like all the time almost, isn't it?
Yeah.
So then aren't you bringing in cold air and heating it anyway all the time, or hot air in the summer? Like, how's that work?
So that old saying, houses need to breathe, in the past, and old structures last a long time because it's like running a hair dryer in your house and it's just blowing out and drying the assembly all the time with your huge furnace. But the more airtight the house is, we need to incorporate mechanical ventilation of some kind. So that's like an HRV or an ERV. It's a heat recovery ventilator. And so what it's doing is it's got its own dedicated duct system, and it's bringing in fresh air into the house and exhausting the stale air out of the house at the same time. It's a little box that sits in your mechanical room. So it's filtering and recovering the heat at the same time. So as it's bringing fresh air into the house, it's exhausting your stale air, it's filtering and recovering the heat as the air exchanges.
There's an air to air exchanger there. So it's kind of warming up there as it comes in with the air that's going out. Whereas in the past, you just have the warm air going out. It's not really warming up the air coming in.
Or you have combustion makeup air in the mechanical room where it's just bringing outdoor air in for the combustion process, where now you've got cold outdoor air just able to enter the house. So just smarter systems, things have come a long way.
That's actually something I've wondered about for a long time. So anyway,
you need to,
no, that's good. Thanks for shooting this quick video. It's good to meet you here.
Yeah, you too.
Awesome.
Right on.